Hello and welcome once again to the Waters and Stanton video channel. I was recently contacted by a very good friend of mine, fellow G3RCQ, Dave. And Dave and I knocked around over the years. We were teenage hams back in the 60s. There was a whole group of us, and so we were teenagers, but we've grown up a bit since then. Anyway, Dave sent me a clip or a link to a video which was all about flagpole antennas, stealth antennas. Now, I don't know whether we are quite the same as the USA. In the USA, it's quite popular to fly flags. And I know that in the USA there's all sorts of restrictions in certain areas about what you can and can't put up. And one of the things you can't put up is antennas. But it does seem to be that you can put up a flagpole. And therefore, if you can make a flagpole as an antenna or make a flagpole function as an antenna, then you've solved the problem. So flagpole antennas are not unusual in the USA. We over here in the UK don't tend to fly flags quite as much. But the technology is quite interesting. Whether you're interested in having a stealth antenna or whether you simply want, for example, a vertical antenna that doesn't take up any space and that doesn't need radials and apparently functions quite well. So I'm going to go through the basic contents of this video that Dave sent me a link to, and I'll put a link below this video as well so you can have a look at it yourself. But there's some interesting facts that come out of this, and I think with a bit of ingenuity you can make a vertical antenna that is fairly inconspicuous but might be quite efficient. Now, the video I've put a link to is on YouTube and it's by W6NBC, and in fact he's published several. Interestingly, John also has a G call sign, M0GCK. He apparently spent several years in the UK and still retains a UK call sign. Most of us are familiar with the classic quarter wave vertical. We have a quarter wave length of wire, and if we ground mount it we have these radials along there, and if we mount it in the air we still have the radials. Not everybody wants radials in their garden. Not everybody's got room for radials in their garden. So we can get rid of the radials. John W6NBC goes into some detail about radials, and he goes back to the days in the past where it was regarded as 120 radials were the ideal or the optimum number of radials for a vertical. But that was really talking about LF and transmissions, where ground wave was the most important part of a sort of medium wave broadcasting and so forth. I think in recent times it's become evident that for HF operation, for HF bands, you don't need that many radials. 16 radials is a sort of an arbitrary figure which seems to be the maximum that is required. Beyond that, the law of diminishing returns rapidly comes into play, and there's no real advantage in adding any more radials. Now, I should say that John has used the Pro version of ESNEC. We do see on the internet quite a few polar diagrams and other diagrams derived from antenna modelling, and there's nothing wrong with antenna modelling if you realise the limitations. And because the Pro versions cost something like about £1,500 plus, there's obviously some inaccuracies in the free versions. So whilst the free versions do give some interesting results, you must bear in mind that those results may not actually be that accurate. Why would you want to have a version that costs £1,500 and all it does was slightly dress up what you got for nothing? No, the ones that you get for nothing are limited in their ability, so do bear that in mind. We don't want radials for whatever reason, so we could have a half wave vertical, and we could feed that with a 49:1 unknown. Don't read radials, and it works quite well, except that it only works on certain bands. It works on its fundamental and it works on its harmonics. It's also going to be quite long. If, for example, this antenna was a massive 20 meters long, it works on 40, 20, 15 and 10. It doesn't work on the walk bands. So that really doesn't fit the bill, because not only is it too long, but we can't actually control the bands that it operates on. It only operates on certain bands, i.e. the harmonics of the fundamental. Another option would be to go to the 9:1 unknown, but my experience with the 9:1 unknown is very much a compromised arrangement. It can be lossy, and so I don't think that's really the best route to go. Now we come to the interesting bit. John found that the most efficient way of constructing a flagpole antenna was to create a vertical doublet. Now, he in his video publishes the details of the measurements he made. Now, bearing in mind he had a 20-foot vertical antenna, which he broke not in the middle but a third of the way down to form a doublet. And it doesn't matter whether you feed a doublet in the centre or move the feed point up or down a bit, it still works exactly the same. And the reason he moved the feed point down a bit was it was easier to access. But the interesting thing is the measurements that he derived. He compared a 20-foot flagpole doublet with a 20-foot vertical with radials. And what he found was that whilst on the 10 metre and 15 metre and 20 metre bands, there wasn't too much difference. But when you got to 40 metres, if you look at his video and look at the results of ESNEC Pro 4, you'll find that on 40 metres, there's about a 9 dB benefit or 9 dB improvement on 40 metres compared with a 20-foot vertical ground mounted and fed against radials. And on 80 metres, there's something like a 13 dB improvement on the flagpole, the vertical doublet compared with a 20-foot pole fed at ground level with radials. So on 40 metres and 80 metres, there's something like a 9 dB and a 13 dB gain. That's quite a lot of improvement. Let me just show you on a diagram basically how he constructed this antenna. Well, I think it's interesting stuff, isn't it? Now we're coming to the end of our summer, but we haven't got to the end of the summer yet. There's plenty of time to get out in the garden and mess about with antennas, and I think this particular idea could be adapted. You don't need a flagpole. You can use the basic principle and adapt it a bit. So let me just summarise what we've been talking about and then see how you can adapt it for your particular small garden or your particular requirement. This is the basic concept that John has used. You've got approximately 2/3 of an element there. He's got a break, and then he's got the remaining third there. The bottom of the antenna is isolated from the ground. There's no radials at all, it's completely isolated. So we've got effectively an off centre fed dipole, and it's fed with balanced line. I think he's used 450 ohm, it's really immaterial, but I think he's used 450 ohm balanced line. He's used balanced line there, and that then goes to an antenna matching unit there. The length of that balance line is immaterial. It doesn't really matter what the length is, but we'll cover that in a second. Now here's the interesting bit. Bearing in mind that the flagpole that John used was approximately 2 inches, I think it was inside diameter. So he's got this, that's basically the upper part of the antenna. Then he's got a break there, not, in other words, some insulator, and then he's got the lower part of the tube coming down there, and the feed point is actually there. The feed point is a third up from the antenna, so you've got the upper part of the antenna, which is metal tubing, forming the part of the doublet. Then you've got the feed point there, and then you've got this lower point there. And he's actually fed it, if I can draw this, probably would be a bit crude actually, but if I can draw this, he's got his balance line going up inside the tube. So you've got the outer part of the tube, the 2-inch part of the tube, and inside he's got the balance line going up the tube. Perhaps if I draw an enlarged drawing of it here, make it a bit clearer. This is 2-inch tube, and inside this 2-inch tube you've got this balanced line going up like that. And the matching unit, bearing in mind this tube is isolated from the ground, the matching unit, the antenna matching unit, is inserted at that point. So you've got the antenna matching unit, a length of balance line going up inside the lower tubing. One side of that balance line goes to the lower tubing, the other side of that balance line goes to the upper tubing there, and that's your feed point. That's your doublet feed point there. Now here's a very interesting point. The fact is that this balance line that goes up inside the tubing is unaffected by the metal around it. Basically you've got a balance line which is coaxially encased in a metal tubing, the 2-inch metal tubing, and John says this has no effect, and this really does confirm what I found, is that the balance line is not nearly as sensitive to its adjacent metalwork as we've been led to believe. Now the other interesting point is that there's an antenna matching unit here, so the balance line goes to this antenna matching unit. So the two leads go down into the antenna matching unit, that's the matching unit there, and then John's got a coax feed coming there. But at that point here, he's got a 1-to-1 balun, not a balun on that side, or a balun on this side. And the reason that he's got the balun on this side is because the antenna matching unit is actually floating. It's actually a floating matching device. So therefore, he has found that the best place for the balun, the 1-to-1 balun, is there, because you do need some form of matching unit, because you've got unbalanced coax here and you've got balance line there. And normally you would expect that the balun would be put there between the antenna matching unit and the balance line in order to give a balanced feed. But John claims, and I struggled with this first of all, but I do now understand it, that antenna matching unit is floating. Therefore, he's put the 1-to-1 balun there, and then you've got your coax feed back to the transceiver. So what we've seen is the basis of a simple 20-foot vertical that doesn't require radials, and we've seen that actually the performance on the lower bands, 40 and 80 meters, seems to be better than an antenna of the same height with radials. Now, what I've done is I've shown you what John used to form his flagpole antenna. So can you build your own vertical antenna without radials fairly simply? Well, yes, you can. Let me just show you two diagrams. I'll just sketch it briefly. One is with a spider pole and an antenna tuner and a balun, and the second one is to actually take the 450 ohm ladder line right back to the radio room, or almost back to the radio room. So let's look at the two ways that you can try this system out for yourself. It doesn't need much work in the workshop, but it might bring some interesting results. If we have a fiberglass pole, telescopic pole, it can be any length, 20 foot, 30 foot or so. That's our pole. Now we run some wire up and down it, and we're going to follow John's recommendation and feed it about a third up from the bottom. But as I said before, it's not critical. So we run this wire down there. It's the wire. We have a gap there, and then we have some wire there. Make sure that the wire is not in contact with the earth, so that you need to terminate the wire about a foot above ground level, something like that. That's basically our doublet, and it can be whatever length you like. Minimum of 20 feet, but you can have 30 feet. And then we're going to attach an auto antenna tuner. We'll attach the auto antenna tuner actually to the fiberglass mast, but for the sake of the drawing I'm going to show it separate here. So we've got the antenna tuner or antenna matching unit there, and that's connected to the doublet here. Now normally on an antenna tuner unit you've got a single output, so one output goes to this long wire there, and then the earth side of the tuner goes to this side there. But bear in mind that that is not attached to earth at all, that's floating. So we've got the main output from the tuner going to this wire here, and the earth side of the tuner going to this side here. Then we have a balun, a 1-to-1 balun there, and that's connected with a short length of coax cable there, and then we have coax cable coming back to the radio shack. So antenna doublet, ATU connected to it, or antenna matching unit connected to it, then a 1-to-1 balun, and then 50 ohm coax going back to it, and the balun is connected with a short length of 50 ohm coax. If you have something like the LDG or MFJ tuners, then they feed DC down the coax line. So you just have a single coax line there. Even though the ATU needs power, it's fed down the coax line. So it's quite simple. Now the second option, again using a fiberglass pole. That's our pole there. And we run wire again down the pole, about 2/3 there and about a third there, and then we take ladder line, take our ladder line, and that ladder line is taken as far back as you can to the radio room, and then you insert either a 1-to-1 or a 4-to-1, it really doesn't matter, balun. You insert a balun there and a short length of coax cable going back to the radio room, and that will then need to go into an antenna matching unit. Now most transceivers have got matching units built in, and you may be fortunate with the right length of ladder line and the right length of coax that you can actually resonate that antenna on several bands, but you may well have to have an external antenna matching unit. The point is that when that coax goes back to the radio room, it needs to either go into the transceiver with a matching unit built in or with an external matching unit. External matching unit gives you a wider range. And both these antennas should give you coverage on all bands from 80 to 10 meters, maybe even 6 meters, worth trying that. But so you've got a very wide ranging antenna using one or other of these options. And that in theory would give you a very efficient vertical antenna system without radials, based on what John has found. Now, there are several antenna tuners, remote antenna tuners you can use. One of the favourites is the LDG. LDG do a nice remote antenna tuner, and the control voltage for operating the remote tuner is fed up the coax cable, so you don't need a separate lead. MFJ do some remote tuners as well, and also ICOM, I think it's the AH4, they do a remote tuner. So any of these tuners could be used directly onto your fiberglass pole. It's an interesting project, isn't it? Now, this channel promotes Waters and Stanton, the Waters and Stanton radio business that's been going for 50+ years. And any of the component parts you need, whether it be the fiberglass pole or the remote antenna tuners, we'd be more than happy to supply. On this channel, what we try to do is not only to mention products, but also promote ideas. And it's my sort of baby on this channel to try and make this channel interesting. We're not only selling gear, but we're also trying to encourage you to try things out for yourself. And I think this is one of the most interesting projects that perhaps you might want to try. It's not too difficult, it's not overly expensive, and it promises to give you very good results, particularly when you're lacking in space or you don't want your antenna to be too prominent. Maybe you could even fly a flag, but I'll leave that up to you. In the meantime, don't forget that Waters and Stanton are more than happy to help you out. Give us a phone call, browse on our website, see what we've got there, and we'll be more than happy to do a deal with you. In the meantime, as usual, you enjoy your ham radio and take care as usual. I'll see you in the next video. Bye for now.